PyPy, how can it possibly beat Python? From the Google open source blog. PyPy is a re-implementation of Python in Python, using advanced techniques to try to attain better performance than Python. Many years of hard work have finally paid off. Our speed results often beat Python, ranging from being slightly slower, to speedups of up to 2x on real application code, to speedups of up to 10x on small benchmarks. How is this possible? Which Python implementation was used to implement PyPy? Python? And what are the chances of a CPython or PyPy beating their score? On a related note, why would anyone try something like this?
Q1. How is this possible? Manual memory management, which is what Python does with its counting, can be slower than automatic management in some cases. Limitations in the implementation of the Python interpreter preclude certain optimizations that PyPy can do, e.g. fine-grained locks. As Marcelo mentioned, the JIT. Being able to on the fly confirm the type of an object can save you the need to do multiple pointer dereferences to finally arrive at the method you want to call. Q2. Which Python implementation was used to implement PyPy? The PyPy interpreter is implemented in Python, which is a statically typed subset of Python, the language, and not the Python interpreter. Refer this URL for details. Q3. And what are the chances of a CPython or PyPy beating their score? That would depend on the implementation of these hypothetical interpreters. If one of them, for example, took the source, did some kind of analysis on it and converted it directly into tight target-specific assembly code after running for a while, I imagine it would be quite faster than Python. Update. Recently, on a carefully crafted example, PyPy outperformed a similar C program compiled with GCC03. It's a contrived case but does exhibit some ideas. Q4. Why would anyone try something like this? From the official site. This URL. We aim to provide a common translation and support framework for producing implementations of dynamic languages, emphasizing a clean separation between language specification and implementation aspects. We call this the Python toolchain _ a compliant, flexible and fast implementation of the Python _ language, which uses the above toolchain to enable new advanced high-level features without having to encode the low-level details. By separating concerns in this way, our implementation of Python, and other dynamic languages, is able to automatically generate a just-in-time compiler for any dynamic language. It also allows a mix and match approach to implementation decisions, including many that have historically been outside of a user's control, such as target platform, memory and threading models, garbage collection strategies, and optimizations applied, including whether or not to have a JIT in the first place. The C compiler GCC is implemented in C, the Haskell compiler GHC is written in Haskell. Do you have any reason for the Python interpreter / compiler to not be written in Python?
PyPy is a re-implementation of Python in Python is a rather misleading way to describe PyPy, imho, although it's technically true. There are two major parts of PyPy. The translation framework, the interpreter. The translation framework is a compiler. It compiles Python code down to C, or other targets, automatically adding in aspects such as garbage collection and a JIT compiler. It cannot handle arbitrary Python code, only Python. Python is a subset of normal Python. All Python code is Python code, but not the other way around. There is no formal definition of Python. because RPython is basically just the subset of Python that can be translated by PyPy's translation framework. But in order to be translated, RPython code has to be statically typed. The types are inferred, you don't declare them, but it's still strictly one type per variable, and you can't do things like declaring / modifying functions / classes at runtime either. The interpreter then is a normal Python interpreter written in RPython. Because RPython code is normal Python code, you can run it on any Python interpreter. But none of PyPy's speed claims come from running it that way. This is just for a rapid test cycle, because translating the interpreter takes a long time. With that understood, it should be immediately obvious that speculations about PyPy or PyPy don't actually make any sense. You have an interpreter written in Python. You translate it to C code that executes Python quickly. There the process stops, there's no more Python to speed up by processing it again. So how is it possible for PyPy to be faster than Python also becomes fairly obvious. PyPy has a better implementation, including a JIT compiler. It's generally not quite as fast without the JIT compiler, I believe, which means PyPy is only faster for programs susceptible to JIT compilation. Python was never designed to be a highly optimizing implementation of the Python language, though they do try to make it a highly optimized implementation, if you follow the difference. The really innovative bit of the PyPy project is that they don't write sophisticated GC schemes or JIT compilers by hand. They write the interpreter relatively straightforwardly in Python, and for all Python is lower level than Python, it's still an object-oriented garbage-collected language, much more high level than C. Then the translation framework automatically adds things like GC and JIT. So the translation framework is a huge effort, but it applies equally well to the PyPy Python interpreter. However, they change their implementation, allowing for much more freedom in experimentation to improve performance, without worrying about introducing GC bugs or updating the JIT compiler to cope with the changes. It also means when they get around to implementing a Python 3 interpreter, it will automatically get the same benefits. And any other interpreters written with the PyPy framework, of which there are a number at varying stages of polish. And all interpreters using the PyPy framework automatically support all platforms supported by the framework. So the true benefit of the PyPy project is to separate out, as much as possible, all the parts of implementing an efficient platform-independent interpreter for a dynamic language. And then come up with one good implementation of them in one place, that can be reused across many interpreters. That's not an immediate win like my Python program runs faster now, but it's a great prospect for the future. And it can run your Python program faster, maybe.
PyPy is implemented in Python, but it implements a JIT compiler to generate native code on the fly. The reason to implement PyPy on top of Python is probably that it is simply a very productive language, especially since the JIT compiler makes the host language's performance somewhat irrelevant.
PyPy is written in restricted Python. It does not run on top of the Python interpreter, as far as I know. Restricted Python is a subset of the Python language. As far as I know, the PyPy interpreter is compiled to machine code, so when installed it does not utilize a Python interpreter at runtime. Your question seems to expect the PyPy interpreter is running on top of Python while executing code. Edit: yes. To use PyPy, you first translate the PyPy Python code, either to C and build with GCC, to JVM bytecode, or to netply code. See Getting Started.
If you're on 14 please come see the subscribe